Today we are talking about MAF, the Microsoft Agentic Framework, which we announced on October the 1st with this post, positioning it as a major turning point in the development of multi-agent systems. And in my opinion, the most important message from this article is this. Microsoft Agentic Framework defines a new abstraction layer because it allows developers to write code that remains independent from LLM model SDKs. In fact, we know that the LLM landscape is highly fragmented. Just on Azure alone, we expose today over 11,000 models, as you can see here. Each provider exposes them through their own APIs. And by provider, I mean companies like OpenAI, like Microsoft for Azure OpenAI, and then Meta, Mistral, Cohere, NVIDIA, DeepSeek. Well, this proliferation of APIs means developers must install a specific SDK for each agent. And of course, they also must use the classes and methods specific to that SDK. Now, with Microsoft Semantic Kernel, we achieved a first level of abstraction. It taught us that to make different agents communicate, we can wrap each one in a semantic kernel object agent. But we also know that to manage or orchestrate these wrapper agents, we must also use the semantic kernel runtime. This creates a dependency on the semantic kernel runtime because we are required to use it to invoke individual agents, and naturally also to use its orchestrator. If we wanted to take that SK agent and move it outside that runtime, we couldn't, because lifecycle, memory, and planning are internal functions of semantic kernel and are not designed as an open standard. In other words, semantic kernel did give us an abstraction layer, but it also created a strong dependency on its runtime. Something that I personally had always taken for granted until MAF arrived, because MAF breaks the dependency on the runtime. It introduces an even higher level of abstraction. It provides standard contracts, which are interfaces like iChat client, and abstract classes like AI agent that any provider can implement through their own extension libraries called MAI, Microsoft Extension AI. These libraries offer so-called adapters that transform proprietary objects like OpenAI agents into MAF agents. This way, agents adapted to MAF become interoperable and manageable without being locked into a specific runtime because they conform to public and documented interfaces. So, MAF is first and foremost a contract framework. Then, if we want to orchestrate them, MAF can also be used as an orchestration framework. And this time, yes, through its own runtime, just like Semantic Kernel. But unlike Semantic Kernel, we are not tied to its runtime to create or orchestrate agents. Anyone can write a MAF-compliant orchestrator without depending on the runtime. And anyone can create and use MAF agents without using its runtime. But there is another dependency that MAF breaks, and it's the dependency on vendor SDKs. As mentioned, the extensions implement an interface required by MAF, which is much more complete than the set of methods in semantic kernel wrappers. This allows developers or frameworks not only to invoke functions in a uniform and provider-independent way, as we said, but also to use a much richer set of functions through MAF's generic SDK. Let's look at a practical example that I've prepared to better explain this concept. If I wanted to limit the response tokens in an OpenAI agent, today I have to use the max tokens parameter in the create method of chat completion. If instead I'm using HuggingFace, I have to use the max length parameter instead of max tokens when we create the pipeline, because that's the syntax required by its SDK. So I get the same result, but with two completely different and incompatible methods. With MAF, I use the common method defined by the contract, namely token limit, so that behind the scenes, or rather via MAI, token limit maps to max tokens for OpenAI and to max length for HuggingFace. With MAF, then, all agents expose the same set of methods, like token limit, but also more advanced methods like trace, apply policy, retry policy, and the developer can use MAF's common methods, which will automatically be mapped to the original ones by the provider's extension libraries. This means that the developer doesn't need to know every single original SDK, and more importantly, doesn't need to write SDK-specific code, which would be not portable, meaning it wouldn't work if we swapped the underlying model with another. I'll close with a subtle but important question. Is the provider SDK always necessary? And the answer is, it depends on how the provider implements its MAI. So two cases. Case 1, MAI is just an adapter. That is, the library simply maps MAF interfaces to the original SDK objects. And in this case, yes, we still need to install the provider's SDK, because MAI doesn't replace the native APIs, it just wraps them. Case 2, MAI is complete. That is, the library includes everything needed to communicate with the provider's service, meaning API calls, authorization, serialization. Well, in that case, we don't need to install the original SDK. Everything is handled by MAF SDK plus MAI. The trend, which Microsoft is encouraging and has already implemented for the AI Foundry SDK, for example, is to produce complete MAI libraries, reducing the need for vendor-specific SDK. Well, I hope I've given you enough insights to consider a truly significant step in the development of agentic applications. And now that we have understood the principles, it's time to see it in action with some practical examples, both for building solutions from scratch and for updating existing code based on Semantic Kernel. Follow me in the next video.